here. I'm here. Let's get started. Good afternoon, everybody. Welcome to a wonderful sunny Monday afternoon at Chem 170 with your host, me, Dr. White. Hi, it's our last week together. Oh, why does this semester go like that? All right, let me give you a heads up for this week, next week, and today. All right, this is our last week. Today, I'm going to go through test number 4 answers. I'll also explain how many points you need to get on the final to get the grade you want. Then I'll start my review for the whole semester. All right, on Wednesday, I'll finish up. Next week, and I'll go through this part again on Wednesday. Next week, on Monday, and I sent out an email, and I'll go through that in a second. I will be giving the 170, Chem 170 final exam. And we won't have class that Monday because I'll send out the password at 1 p.m. You'll have until next day, 11 Tuesday, a week from tomorrow, you'll have to get the final exam PDF file uploaded to Blackboard. Now, interesting thing, because ECC doesn't have an official finals week, I'm required to have class on Wednesday. If we were to face-to-face, I'd still have that. And therefore, I'll have class. If nobody shows up the first half hour, I'm going to say goodbye because we have no lab. That would have been we would have checked out already. So that's coming attractions. And let me open up first. Hold on. I should open this up first. Let me go through this first, and then we'll go through test number 4 answers, which I will be removing from the video. All right. Thumbs up, people. Do you see Chem 170 final information on your screen? Thank you. All right, let's go through this. All right. The final exam will be given on 5/16/22, Monday, a week from today at 1 p.m. At that time, I'll be emailing you the password. We will not have any Zoom meeting that day. And you'll have until Tuesday, the next morning, to take the final exam and upload your answers to the final exam as a single PDF file, like you've been doing all semester for the hourly exams. Now, normally when we do this, I give students, like a normal final at other colleges, 2 hours. Actually, I give them more. So please take up to 3 hours, but relax. Normally, when I'm doing it face-to-face, almost all students are done in 75 to 90 minutes. And relax, because you're going to see something and say, what? No, relax. All right. The Chem 170 final exam has 32 problems, 18 pages. It's like 2 hourly exams slammed together, but it's a little easier. Some of the problems have multiple parts. I've never given a multiple choice test question on or final exam question in 170. I never will. All right. Now, here are the point breakdowns. There are 2 ways I can break it down, and I did. One is 30 points general knowledge, nomenclature 62, reactions 118. If you notice it adds up to 210, that means there's 10 bonus points. Am I nice or am I not? Don't answer that. But anyways, that's one way. Another way of looking at it is broken down by test. Test 1 material, there'll be 35 points. Test 2, 60. Test 3, 58. Test 4, 53. A new material, amino acids and proteins, 4 points. And it still adds up to 210. 10, 10, 10 bonus points. Now, one of the questions you might ask is, how come you're only asking 35 points on test 1? Well, I'm not at this point in the game going to ask you how many carbons are in the longest chain. You already know how to do that. And things like that were simple. Now, back when you took test 1, they weren't, but you've repeated over and over again and used those skills and other things on test 2, 3, 4. I'm not going to repeat it on the final. All right. Now, by Sunday morning, this Sunday morning, I should have the final exam PDF file and the instructions in D2L. And I'd recommend, if you'd like to, download it on that Sunday before next Monday. All right, if you have any questions during the final exam, please email me while you're taking the final exam. I'll be checking my email every couple hours, and I'll also have my office hour that night. So if you still have questions. Now, I will be posting the final exam scores along with your final Chem 170 grade in by Friday, 1 p.m., a week from this Friday or earlier in D2L. Now, at that time, I'll send out an announcement like I've done with the hourly exams and send you an email that your scores and final grade are in D2L. The official system, My Access or My Access or ECC Access, whatever. Schools have different similar names. I always get them mixed up. But anyways, let's find out. ECC Access. That usually can take anywhere from 12 to 24 hours after I post it in the ECC Access. It's when they refresh the database. That takes time. But the grade in D2L will be your grade for the course. Now, one thing I do not do, and I don't do this when we do face-to-face, I won't be sending out emails, which how many points you got on what questions on the final. I just don't do that. However, I will tell you this, anybody within 15 points of a cutoff, I automatically go back and regrade their whole final. That way I can make sure I haven't made any mistakes. In all the years I'm doing this, I have not. And that's the final exam. On the final, there will be, I don't know how many, but some give the starting material or synthesis problems in the reaction, but only a small amount, just like during the semester. What's the best way to study for the final? One, come to or watch my reviews today and Wednesday. Secondly, use your hourly exams as practice problems. If you can retake the hourly exams and get the right answers, and if you're not sure, always feel free to come to my office hours for help. You'll do excellent. Now, when you look at that and say, 210 points, well, historically, divide that by 2, that would be the same as an hourly exam. Historically, on this final, my students got about 170 to 185 average for the whole class. Yes, 180 would be an A, 90% out of 200, because the 10 are bonus points. So it always makes me happy and surprises me too that students do extremely well on my final, face-to-face and online. Any questions before I go to test number 4, answer coverage? And if you want, you always come to my office hour or email me. All right, let's go through test number 4. I'll cut this out of the video, the test number 4 answers, and afterward, I'll explain how to figure out how many points you need on the final to get the grade you want. Oh, the silence is deafening. Who said that? Anyways, I just did, but somebody else said that as a quote. All right. I would have a question if I were in your shoes, and that is, how many points do I need to get my grade I want on the final exam? Or another way of putting it, what's my current grade? I think the first place is better. Let's go to the whiteboard. If I had opened it, all right. Let me close this. Let me go here, hang in there. Oh, quick question for all of you. How's my signal going? After I increased my internet service, the company I was with got bought out by another company, which I knew about, but officially happened a couple of days ago. Guess what? They don't offer the same service quality as the company I was with. It's better than Xfinity, but it's not as good as what it was. So I changed it because I had gone to faster download speed. Because of that download, I got a faster upload, because I had been getting 100 downloads and upload. And with the one I had changed to before this company took over was 500 download, 50 upload. Well, it turns out their best download at equivalent 400 is only 20. And at 150 download, which is a lot cheaper than the 400, their upload is only 15. And if you go to 1 gig on this new company, their upload is only 20. Yeah, really, that's how I felt. But anyways, so far so good. Yesterday, I had problems when I had to register my modem. I was on the line for about 40 minutes with customer service. I kept on telling them, I got a class to teach tomorrow. We got to work this out. And luckily they did. They were pretty nice about it, but what I didn't need. All right, let's talk about something more relevant to you. And let me get the whiteboard up. Now I got it open. All right, let's say X, well, not say, X is the total test points, so your 3 highest tests. By the way, that number is now in D2L. I uploaded it when I uploaded your test 4. And I also have in there graded the extra credit. And let the addition of the 3 test scores, highest test scores, plus your extra credit is X. Now, to find the points needed for an A, take 450 minus X. And that gives you a number Y sub A, which tells you how many points you need to get an A. This is assuming you've handed in all your labs, which most of you had. And 400 minus X gives you a Y sub B. That's how many points you need for a B on the exam. And C, I don't think I have anybody in this class lower than that, but I'll do it. Like I said, thank goodness, I don't think I have anybody at this point. But again, this is assuming you handed in all your labs. Or if you're missing one, remember I dropped one lab. All right, let's take a look at calculation. Let's say on each test you had 100 points. So your X, and you didn't do an extra credit, is 300. So 450 minus 300 equals 150. I did my math correctly. If not, somebody help me out. And that means to get an A, you need about 150 points out of 210. But you say, oh my goodness, 150? Well, if you divide that by 2, that's the same as getting a 75 on my hourly exam. So that's how it works. Now, again, this is predicated, you've handed in all your labs. If not, you've got to figure out on your own, take the total points, multiplied by 0.9 and subtract from that your X plus your lab points. And that tells you how many points you need real. But this works, this is quite accurate. Now, I do have a warning for all of you, and a number of you, this is pertinent. You're going to do that and say, oh, I don't need that many points on the final. And I've had a number of students do this and say, oh, I don't need that many points. I'm not going to study that hard. And they bomb the final. Do you still use that term when you really do bad on test or final? You bomb it. And they, excuse me, I've had students bomb it and they lose where they should have gotten this letter grade. They lose one letter grade. And I've had a few go from like an A to a C because they totally did bad on the final. Don't. Study the final like you need for the final, like you need every point. Again, even if you don't need it, study for the final like you need every point. And the best way to study is one, either come here or watch the video for when I'm going through the review today and also on Wednesday. Don't forget to hand in the lab that's due on Wednesday. And also use your hourly exams as practice problems. And can I put the identical problems on the final? No. But if you look at my practice problems you've used all semester, weren't they similar to test problems? Yes, because that's why I call them practice problems. So that's how you do good. My students usually do good. They follow that and also watch or come to the review. All right, any questions on any of that? Going once, going twice. All right, let's start the review. All right, everybody see test number 1 review on your screen. And this helps students going through, and they've told me that over the years, so it's why I keep on doing it. All right, long ago, we started out with hydrocarbons. And you should know hydrocarbons are molecules with only carbon hydrogen atoms. And there are 2 types of hydrocarbons. One is saturated, the other is unsaturated. And a saturated hydrocarbon is a molecule with only carbon hydrogen atoms with only carbon-carbon single bonds. Unsaturated, like you learned about unsaturated fats, has but an unsaturated hydrocarbon. Hydrocarbon means it's a molecule, only carbon hydrogen atoms, and has at least one carbon-carbon double or triple bond. Now, I talked introduced you. Hello, say hello to the alkanes. Oh, that was awful. I'm sorry. But anyways, those are acyclic saturated hydrocarbons. I'll never ask that on a final. And the cycloalkanes. And I introduced you to one of the important things, how to draw molecules. And time out for a public service announcement from Dr. White. One of your friends on the final exam is this. How many bonds to carbon are there? Oops, let me fix that finger. Four, no ring, but four bonds to carbon. When I grade a final, especially for reaction problems and structures, for nomenclature, if I've seen 5 bonds to carbon, I start laughing, and my eye immediately tells my hand to put 0 in when I'm grading. In the spreadsheet, used to be the red pen, but I'm on a keyboard now. Remember, anything you draw a structure, make sure there's always 4 bonds to carbon, never less, never more. What was that? Said the raven, nevermore. Oop, doing poetry now in class. Who's the poet who did that? I vaguely, it's at the tip of my tongue. Nope, not there. All right, let's get back to work. But seriously, check. I taught about IUPAC, which means the official name, even though you learned Dr. Whitelaw loves to say International Union of Pure Applied Chemistry, but that's the official name. And we learned you learned how, I already knew how to find the longest chain to name the root name. We talked about, and I showed you the alkyl names that you learned, methane through decade. Then you learned about alkyl groups, substituents, methyl, 1 carbon, 2 carbons ethyl, 3 carbons to the end, N-propyl, 3 carbons to the middle, isopropyl, and 2 of the 3 butyl groups. The third one I've never seen except once in a lab at another school, all the years I've been doing organic. And 4 carbons N is N-butyl, and one of my favorites along with isopropyl, but I love 4 carbons, 3 to center carbon that's attached to a ring or a chain, tert-butyl, or as organic chemists normally do, T-butyl. Ha! I forgot to change this. And real world uses. Anybody find any gooseline lately? Gasoline are alkanes, propane, natural gas, Vaseline, baby oil. Now, I only had one reaction, and that was if you take an alkane or cycloalkane, react with oxygen, which I did have that question on test number 1, gives you carbon dioxide and water. At this point, I gave you a huge gift. Organic chemists are lazy, and for this class and most of what we do, we never balance chemical equations, which you didn't have to do for my class. Yay. All right. Next, I talked about the alkenes and alkynes. The alkenes are carbon-carbon double bond. Alkynes are a carbon-carbon triple bond. Remember, each line is a pair of electrons of a covalent bond. And in alkenes, double bond, one of those bonds is a pi bond, one is a sigma. Again, in an alkene, one of the bonds is a pi bond, the other is a sigma bond. Now, in alkynes, a triple bond, 3 lines, you have now 2 pi bonds and 1 sigma bond, 2 pi bonds. Now here the mistake should be the whole ANE gets dropped. For IUPAC names, you have a double bond, find the longest chain with both carbons, double bond, name it as an alkane, drop the ANE ending, replace with ENE, and a number for acyclic, plus don't forget cis and trans. When you're in a ring, no number and no cis or trans, because in this class and everything I've ever done, it's always going to be cis if it's a small ring, which was what we do. Now, let me remind you about cis and trans. if we find what, and this I'm showing the 120-degree bond angle for a double bond. All right, now, longest chain, 1, 2, even though it's bent, it's still a chain, 3, 4. Butane, double bond, butene. The carbon, no matter which start end of the chain you start naming, the carbon of first carbon double bond close to the end is 2. But you look for 2 atoms or 2 groups that are the same, one on each carbon, and notice the hydrogens are on the same side below that dotted line, the plane, and we call same side cis. So that would be cis-2-butane. This is double bond, 4 carbons on carbon number 2, either way you count it, that's 2-butene. But now, notice these hydrogens are on opposite sides of that line, and opposite is trans. Remember, cis means 2 groups or 2 atoms are on the same side and that plane orthogonal to the double bond, which is where this dotted line is right here, and trans opposite. Oh, I have to. I don't have to, but I want to. And you all know that's transparent. Ooh. All right, let's continue on. Now, for a triple bond, find the longest chain with both carbons of the triple bond. That should be dropped to ANE, replace it with YNE and a number. I have never seen in my actual life, other than one time decades ago, a ring with a triple bond in it. And in a triple bond, you can't have cis or trans, because a triple bond is linear, not bent like a double bond. Now, there's one common name for a triple bond, which I did ask on test number 1. Nobody ever calls this ethine. It has the common name acetylene. And that's the simplest alkyne, 2 carbons bond together in triple bond. And that's the gas with oxygen that's used for acetylene torches, which are very hot, which is how they can melt metal to help you break into a bank vault. All right, now I started talking about reactions. And the first thing I taught you was, whenever you're doing a reaction, look for what's different. What's not a carbon-carbon single bond or a carbon or a hydrogen atom. That's where the fun is, the functional group. That's where the fun is. And so the first reaction I taught you was, you take a double bond in any molecule, react with a hydrogen catalyst, and the catalyst can be nickel, platinum, or palladium. You break the pi bond, and each carbon gets a hydrogen. And this was the first time I taught you about the other important thing, which I will now do. Time for final exam public service announcement number 2. And that is, when you're taking an exam, Do you break carbon-carbon single bonds? Except for combustion? No, you don't. You just don't. End of public service announcement number 2. And the question is, give the organic product or products are the following. What do we see that's different? A double bond. What are we reacting with? Hydrogen and a catalyst. That's what platinum is. And a catalyst can be nickel, platinum, which we are using, or palladium. And you break, remember, it says 1 pi bond. Hold on. I'm having a bad pi drawing day. Now I'm having a better one. 1 pi bond, 1 sigma bond. You break the pi bond, and each carbon gets a hydrogen. And here are my 2 carbons, the double bond. Do you break carbon-carbon single bonds? No. So you end up with 3. Break the 1 bond between those 2 carbons, that pi bond. Each one gets a hydrogen. You know, there's 4 bonds to carbon. And I can do this. Now, you could have written it CH2, CH3, but why do an extra step when the person grading the final, me, I tell you I'm that close to the person grading the final, it's me, allows you to do that. So remember, you don't break carbon-carbon sigma bonds or single bonds, but pi bonds, you can break like that. Next reaction was, if you take a double bond, in organic chemistry, we use the letter X for a halogen. In this case, halogen gas, X2, and X can be, for this reaction, fluorine, chlorine, bromine, or iodine. You break the pi bond, and each atom carbon of the double bond gets a halogen. Oh my goodness, time is really zooming this last week. Excuse me, time for a 5-minute break. I'll see you in 5 minutes. I can get up and stretch. See you in 5. Oh no, I'm running late. Time to get started. All right, let's go back to where I finished off. Is talking about halogenation. Take a double bond, react it with halogen gas, and each carbon gets a halogen. Now, this is symmetrical addition to double bond. We're adding the same thing to each carbon, hydrogen or halogen. What happens when you have unsymmetrical addition to a double bond? And the first case I taught you was the double bond reacting with HX, hydrohalogen acids, where X in this case chlorine, bromine, or iodine. You break the pi bond, one carbon gets H, the other gets X, and it follows Markovnikov's rule, M's rule. And that is the carbon with the most hydrogen, the double bond, gets the hydrogen, the other carbon gets the halogen. And since I didn't give you anything to have fun with our first hour together, here's one for you. Give the organic product or products for the following reaction. 3 points each. All right, I think everybody's done. My turn. What's different? What's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? A double bond. We're reacting with HBr. Remember, halogens are X. For this reaction, it can be chlorine, bromine, or iodine. Remember pi bond in a double bond and sigma bond. And you break the pi bond, one carbon gets H, the other gets X, and it follows Markovnikov's rule, and that is the carbon of the double bond with the most hydrogen gets the hydrogen, and the other gets the halogen. And now you have to use our high-level math skills. This has 2, this has 0, which is the larger number, and time's up. Hopefully I'll pick 2, which means you break carbon-carbon single bonds. No. So I have this. Here are my 2 carbons, double bond. This one had the most hydrogens, so it gets the hydrogen. The other gets the halogen, which is bromine. And I know there are 4 bonds to carbon, so I can put in my hydrogens. And that's how you do Markovnikov's rule, or use it. Now, you can also add water and acid H plus. This class, there are different ones, sulfuric acid. I didn't talk about methane or toluene sulfonic acid, similar to sulfuric. You wouldn't want HX because you have the reaction on top going on too. All right, what is water? Water is HOH. And you break the pi bond, one carbon gets H, the other gets OH, and it follows Markov-Nikov's rule. The carbon with the most hydrogens gets the hydrogen, the other carbon gets OH, which, as you learn later on, is called the hydroxyl group. Oh, let's have some fun with that. Now, here's some fun for you to have. Have you noticed if I say fun enough, you think it is, but it is. Give the organic product or products for the following. Oh, I can't believe the semester is almost over. Seems like just yesterday I was teaching you 4 bonds to carbon. And good news, later today I get to move my winter shirts back to the closet where I don't use them and take out from that closet my short sleeve shirts. Well, this is the latest I've ever done that. Usually I do it by April. But if you look at the weather, it's going to be warm this week. That means I better uncover my air conditioner too. I might be using it tomorrow. All right, let's do this. What's different? What's not a carbon or hydrogen or carbon-carbon single bond? Double bond. Reacting with acid, H plus, water. Remember, water is really HOH. You break the pi bond, one carbon gets H, the other gets the hydroxyl group OH, and it follows Markov-Nikov's rule. Oh no, there are no hydrogens on the ring. Well, there are, we just don't show them. And now you have to know there's 4 bonds to carbon. If I look at this carbon, I count 1, 2, 3 bonds. 4 minus 3 is 1. So there's 1 hydrogen there. If I look at this carbon right here, how many bonds? 1, 2, 3. Don't forget this one, 4. 4 minus 4 equals 0. So do you break carbon-carbon single bonds? No. So I'm going to end up with a ring. I have my methyl group, and the carbon with the 1 hydrogen will get the hydrogen, which we don't show on the ring, and the other carbon will get the hydroxyl group, which we do. Now, if you put the CH3 here and the OH over there, like this, for this class, it would be totally correct. Okay, and that's how you use Markov-Nikov's rule for this reaction. Next, we talked about triple bonds. And triple bonds have 2 pi bonds and 1 sigma. So if we do hydrogenation, adding hydrogen, because organic chemists are lazy and we don't want to balance the chemical equation. If you look right here, we have bracket X, S, close bracket. And that's shorthand for excess. That means you have all the hydrogen in the world to allow hydrogen to react with anything it could. In this case, the 2 pi bonds. So you break the 2 pi bonds, sigma bond you don't, single bond, and each carbon of the triple bond gets not 1, but 2 hydrogens. Same thing with halogenation. And halogenation, halogen gas, and again, since we don't want to balance it, we use bracket X, S, close bracket, excess. I have all the halogen gas in the world that react with anything halogen gas will react with, and that's the 2 pi bonds in the triple bond, and each one carbon gets 2 halogens. Next, I talked about aromatic compounds, and those are compounds originally found in spices and herbs. And you remember we had our lab where you smelled cinnamon and all sorts of good things. Well, the simplest aromatic compound is benzene. And benzene is a 6-membered ring with 3 double bonds that are conjugated. You can write it this way, or you can use the cyclic form. That's not the right term. I don't even use it that often, so I forgot the name of that. The delocalized pi bond form with a circle in there. All right, a couple of things I forgot to mention that will help you on test 1, which I did. I better talk about it on the final. Now, here, give the IUPAC name for this. Well, 6 carbons is hexane, but it's a ring, and you need cyclohexane. Common mistake on the final exam, people forget the cyclo, and I mark it wrong. Next, draw the structure for benzene. And students do this. And that's cyclohexane. No, either have to do this or this is the other resonance form of the Kekula structure, or the delocalized. I like the first 2 better. They look cooler. This. If you don't put something inside the ring like that, it's cyclohexane, and it's wrong. And I'll mark it that way. So remember that's a common mistake on the final exam, like on test 1. Now, when you have a methyl group, by the way, benzene, IUPAC took the common name and made it the IUPAC because that name has been around for centuries and they weren't going to change organic chemists. Now, same thing with the next one. When you have a methyl group on a benzene ring, it's not called methylbenzene. It's called toluene. And that's how you do it. Now, when you have disubstituted, I taught you to use the words ortho, meta, and para. Ortho is 1,2 disubstituted, meta is 1,3, para is 1,4 disubstituted. I taught you some more substituents. When you have a halogen chlorine, it's called a chloro group. When it's fluorine, it's fluoro, Br, bromo, iodine, iodo, and NO2 is called a nitro group. Remember, what you're looking at is hidden in the secret file in the lecture section of D2L called test number 1 review. So if we look at this, let's practice 1 or 2. And the question would be, give the IUPAC name for the following. Your turn. Excuse me. Even though we won't get to it today. Any of you been out this weekend? I think I mentioned, if not, I had some quality time I spent with my lawn and lawnmower this weekend, among other things. And if you're outside, even today, did you smell the flowers and the scent from the trees and everything that's blooming? Do you think those are esters? They are. One bad thing about Zoom teaching, when students don't have their video cameras on, is I can't ask when you're done, look up and smile. I can do that in a face-to-face class. All right, I think everybody's done. Let's take a look at this. How do we do this? Ooh, this is a ring with double bonds. There are 3 of them. They're alternating single, double, single, double, single, double. That's benzene. And the root name is that. Then we have an ethyl group and a bromo. And notice they're 1, 3 disubstituted. 1, 3 is meta. Now, there's 2 types of nomenclature question. One is, here's the structure, give the IUPAC name. The other is, here's the IUPAC name, draw the structure. And why don't you draw the structure of pyronitrotoluene? We'll say that 5 times quickly. You don't have to. And when we went through double and triple bonds, you go back and look at test 1. There are questions. Here's the names, which were double or triple bonds that you have to draw. Well, I haven't done this all semester. Those of you watching on the video, make sure you try this out too. If you need more time, hit the pause button. All right, let me get to work. How did you code this? All organic names start from the right, move left. Toluene. Don't forget the circle or the bonds. And nitro is NO2, pyramines 1, 4. This is 1, doesn't matter if you go clockwise or counterclockwise. This is carbon 4, nitro group is NO2. And as I showed you and talked about Alfred Nobel and he and his brothers worked to make this compound safe in a product they called dynamite and other explosives they sold. What would be the IUPAC name for this? Methyl group on benzene ring, toluene. In organic chemistry, 2 is di, 3 is tri, NO2, trinitro. And when there's more than 2 substituents, use numbers. The methyl group is 1. And notice this is 2, 4, 6, trinitrotoluene, otherwise known as TNT. And I have that on test number 1. Oh, I forgot something. Notice how he saves up all the bad humor for the last week of class and flicked you one more time. And everybody know what that is? Of course, paramedic. 1 for paramedic and TUI. All right. Now, remember I talked about having the double bonds, holding hands, making them conjugated. That makes them very stable. And Mother Nature doesn't like to make things less stable. So unlike a double bond, breaking the pi bond is okay. In benzene, you don't have addition reactions. You have electrophilic, nucleophilic substitution, electrophilic aromatic substitution. And that means you replace one of the hydrogens on the ring with something else. And I taught you a couple of reactions. And the first one is if you take a benzene ring, it reacts with halogen gas and a catalyst, FeX3, ferric trihalide, you replace one of the hydrogens with a halogen. And since I'm not going to teach you directors in this course, therefore, that's the only one I can ask. Now, if you take a benzene ring and react it with nitric and sulfuric acid, you form an NO2 plus, which attacks the ring, and you put a nitro group on there called nitration. And if you take SO3 and H2SO4, you'll put a sulfonic acid group, which is important in making our daily detergents. And finally, I talked about something very special, very rare in all of organic chemistry, whenever you can make a carbon-carbon single bond. And this is called Friedel-Crafts alkylation. You put on an R group and alkyl group. By the way, this is where I taught you R is like the variables X, Y, and Z in math. But in organic chemistry, that means it's something that has carbohydrates in it. And here, if you take an alkyl halide and aluminum trihalide, where X can be bromine or chlorine with benzene, you put on a R group, make a carbon-carbon single bond. Remember, the bond from the benzene ring to the R group is on the carbon that had the halogen. I'll say that again. The bond from the benzene ring to the halogen, or to the R group on the RX, is to the bond from the benzene ring to the carbon in R that was originally bonded to the halogen. And it's your turn. Give the organic product or products to the following reaction. right, let's take a look at what's different. Ooh, a benzene ring. What do we have here? Carbon, oh, a carbon with a halogen alkyl halide. This is my R group. Oh, aluminum trihalide. Remember, X for this is chlorine or bromine. I've never seen anything else. And you do that special thing. Remember, you don't break those bonds in the benzene ring. You don't put that in there. It's cyclohexane. Mark it wrong. Please don't. And you get a carbon-carbon single bond. So this is my benzene ring. Which carbon has the halogen? The second one. Do you break carbon-carbon single bonds? No. So I'm going to have the second one bonded, and that has 4 carbons in the R group. And we have finished the material for test number 1. Let's move on to test number 2 review. And now we started getting some really good functional groups. And the first one is an alcohol. An alcohol is an OH group on a carbon, OH being hydroxyl. And how do you name alcohols? You find the longest chain with the hydroxyl group, name that chain as an alkane, drop the E, add OL, and for acyclic, you need a number. What carbon is it on? For in a ring, you don't need a number because that's the only functional group that's always going to be number 1. Now, there's a special alcohol that the IUPAC name was taken from the common name. They're the same. And that's a benzene ring with an OH group, and that's called phenol. I know you say it's phenol, and that's phenol. Now, I also did teach you common names for alcohols. And for common names, as I said, all semester, I'll only ask you to, here's the common name, draw the structure. I'll never ask you, here's the structure. Well, I shouldn't say never, but in these chapters I did, and I did for amines and amine salts because nobody uses IUPAC names for that, and quaternary ammonium salts. All right, for common name, name the R group attached to the OH group as the alcohol, as the alkyl group it is, and then add the word alcohol at the end. And where do you see this? Well, if you go to the supermarket or big box store and you buy rubbing alcohol, where it's 70%, or nowadays you can even buy up to 90% isopropyl alcohol plus 30% water. Now, how do you make an alcohol? Well, you've already seen this reaction. Double bond, acid and water. You break the pi bond, one carbon gets H, the other gets the OH from water, and it follows Markov-Nikolov rule. Now, probably one of the hardest reactions this semester was the reaction of an alcohol with sulfuric acid called dehydration of an alcohol. And here you heat it up, that's with the little triangle, and usually I don't put the temperature, but you got to heat it real high, and sulfuric acid, and you have a carbon with a hydroxyl group, an adjacent carbon, and you lose both water, and between those carbons you form a carbon-carbon double bond, and this is called Zaysev's rule. And Zaysev's rule is you get the double bond that has, if you have 2 choices, you get the double bond that has the most, listen, the most carbon atoms directly bond to the carbons of the double bond. And that's your product. Now, in real life, that's your major product. For my class, I'm making it the only product. And your turn. What would be the product or products for this reaction? And if it's involving somebody's rule, there's only one product. Any of you out there try any of my suggestions? One person already told me they tried using Barkeeper's Friend in their bathroom on the tub and everything. It worked real good. Anybody tried the hair and grease remover yet? Let me know by email if it worked for you. Always curious. All right, I better get a poll out. Time for you to vote. All right, time for me to get to work. So if we look at this molecule, what's different? Hydroxyl group on a carbon. We're reacting with sulfuric acid and heat. Therefore, you need an adjacent carbon with a hydrogen, which we do. And you form a double bond by losing water, and it follows Zays's rule. And that is the carbon, the double bond product you get is the carbon, the molecule that has the most carbon atoms directly bonded to the carbon with double bond. Now, if we look up here, we have a hydrogen there and a hydrogen there. If I lose a hydrogen from A in the hydroxyl group, oops, I forgot a hydrogen there. Somebody should have caught me. All right, and if we lose the hydrogen from A in the hydroxyl group, here's the alkene we would get. Now, if we lose the hydrogen from B and the hydroxyl group, this is what we get. Notice in both cases, I start with 5, I end up with 5 carbons. Now, if we look at A, how many carbon atoms are directly bonded to the carbons of the double bond? And the answer is 1. Hold on 1 second. If we look at B, how many carbon atoms are directly bonded to the carbons of double bond? And therefore, this has 1, this has 3. Which is the larger number? And time's up. Hopefully you all picked 3. And Zayseth's rule, the way I'm teaching it, that's the product you get. Because that's the product that has the most of those 2 choices, carbon atoms directly bonded to the carbons of the double bond. And that's how you do Zayseth's rule. Now, some simpler reactions. If you take an alcohol and react it with HX, where X can be chlorine, bromine, or iodine, you replace the halogen, and on that carbon, the halogen is bonded to, or the alcohol is bonded to, you replace it with a halogen. But if you had a molecule that had a double bond and you want to replace that OH group, the alcohol also in the molecule with a halogen, use thionyl chloride, SOCl2. And here, you replace the hydroxyl group with a chlorine. Ooh, let's have some fun. Oops. Let's change something. And the question is, what would you start with to make that molecule? All right, my turn. If we look here, what's different? What's not carbon? What's not hydrogen? Ooh, a halogen, chlorine on a carbon. And that's our X. But in this case, it's not this X, it's chlorine. And why is that important? Because of this. And if you take an alcohol reactor with thionyl chloride, you replace the hydroxyl group with a chlorine. So what's my R group? Yeah. 4 carbons, a methyl group. Which carbon has the halogen? That one, which is this one, will have the alcohol. And that's how you do that. Now, I will never ask on a test, but you can have primary, secondary, and tertiary alcohols. If you take a primary alcohol and oxidize it and use the bracket, O close bracket, for oxidation, and there are different oxidation reagents you can use, but my class, I'm not asking you to learn them. And that would be you lose the hydrogen from the alcohol, hydrogen from the carbon the alcohol is bond to, form a carbon-oxygen double bond, and you get an aldehyde. And if you take a secondary alcohol and oxidize it, you do the same thing, and you get a carbon-oxygen double bond, and that's called a ketone. And that's everything I taught you about alcohols this semester. Now, next I talked about thiols. Thiols are the sulfur equivalent of alcohols. Instead of ROH, you have RSH as being sulfur. And those are called thiols. And the important thing you should know is, one, they stink. Whoa, do they stink? Have you ever been by where a skunk let loose? You know that's stinky. And the important thing you should remember are thiols are put in natural gas so you can smell a leak. And I talked about the natural gas explosion in that tragic Texas school accident, where almost 150 students and teachers were killed. Many others were horribly burnt. And after that, the Texas State Commission came up with the idea, let's put a thiol into natural gas. And now everywhere in the United States, if any of you have been outside the United States, I can't remember the times I've been in Europe. Most times I was in restaurants anyways, when we were near gas. But I'm sure they put that or something similar in natural gas. All right, let's continue on. Now, when you replace the H with an R group on an alcohol, we have an ether. And an ether, as I taught you, is, first of all, I didn't talk about it, but it's a very good reaction solvent instead of using water, which is not good in organic chemistry. And it's also been used, certain ones, as inhalation anesthetics. And nobody uses IUPAC unless you're writing a patent or a legal document. We use common names. Name each R group as the alkyl group it is and add the word ether on it. Now, here's the Williamson ether synthesis reaction. Take an alkoxide, alkyl halide, you form an ether plus salt. The carbon with the halogen is the carbon, the oxygen is bond to an R prime in the ether. The carbon that the oxygen is at the alkyl, the carbon R prime that the alkyl halide is bond to, is the carbon in the ether in R prime that the oxygen is bond to. If you remember test number 2, I gave you a synthesis and I also gave you reactions. And what would be the organic product or products for following reaction? Your turn. All right, my turn. If we look at the first one, what's different? Well, I've got carbons are oxygen minus side, sodium cation, alkoxide. Ring, then that's not, oh, a carbon on it. I have carbon, put a chlorine on it. Yeah, rings always do have a carbon on them too. Put a chlorine on it, and that's an alkyl halide. And what do you get in ether? Now I'm going to put down salt. You don't have to, because if I give a synthesis like I did test number 2, this helps identify what X is. But for this one, we don't. This is R prime, R oxygen, and my 6-membered ring. Well, that's an interesting ether. Next, I talked about ethylene oxide. At first glance, say, oh, that's an ether. No, because it's in a 3-membered ring that's very strained and wants to pop open and get rid of that strain being crowded. It's a different functional group, and we call that an epoxide. And I only taught you about one, ethylene oxide, which is the common name, not the IUPAC. And if you take an alcohol reactor with ethylene oxide, the H goes on the oxygen, the OR goes on one of the 2 carbons, and the other one gets the OH, you make an ether alcohol. Now, if you react the alcohol with N moles of ethylene oxide, you get a polyether alcohol of this structure, where N is the number of times OCH2 is repeated. Guess what? You're going to have to wait until after break to have some fun with one of these 2 reactions. With that, I'm going to take another 5-minute break, get up and stretch, get my leg muscles all happy, and I'll see you in 5. Let's get going. Now, I was talking about reactions of ethylene oxide. And let's do one. I should mention both of these reactions, I will never give a synthesis reaction. So let's take a look. And here's a reaction for you to try. Give the organic product or products for the following. All right, my turn. And if we look, remember when you look at a molecule, look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon shift. Ooh, OH group on a carbon, alcohol. Plus, ooh, 5, I'll call that N, and ethylene oxide. And what do you get? You get this polyether alcohol. And in this case, what's R? An isopropyl group. Then N is 5, so I'm going to have OCH2, CH2, close bracket, what's N? 5, and then OH, and now I better put in the rest of the hydrogens, because you know there's 4 bonds to carbon. And one common mistake students make, they put the hydroxyl group here inside the bracket. No, nothing like that exists, and it's wrong, so please don't. And I showed you how when R is a nonal phenol group, that's used to make a spermicide that's used for many things. Next, we got into one of my favorite functional groups. That's aldehydes and ketones. And an aldehyde is a carbon double bond to oxygen with a hydrogen and an R group on it. A ketone is a carbon double bond to oxygen with two R groups, R and R prime. And I introduced you at this point, I did it with the ethers before. R and R prime are like in math, X and Y, different variables, in this case, different number of carbons and hydrogens. They can be same or different. Now, I'm going to come back to what nomenclature, but one of the important things in all of organic chemistry to me, Dr. White, is the carbonyl group. And I asked you to learn what is the carbonyl group, how to draw it, and how to describe it with words. And the carbonyl is a carbon double bond to oxygen. Oh, I've got that on the screen. It's not a functional group. It's found in a number of functional groups. So you should know that. Ooh, it even says IMP on there, important. Now, nomenclature for aldehydes. Find the longest chain that has the carbonyl carbon, carbon double bond to oxygen, name it as an alkane. Drop the E, the longest chain, name it as an alkane, drop the E, add Al. You do not need a number which carbon is the carbonyl carbon because it's always one in an aldehyde. And all the rest of the substituents you name like you've already done. And that's aldehydes. Remember, alcohol is OL ending, aldehyde is AL ending. Make sure you write your O or A clearly. All right, now one special aldehyde, which IUPAC took the common name and made it the IUPAC, is when R is a benzene ring, and that's called benzaldehyde. And if you remember, that smells like either cherries or almonds. I can smell both at the same time. Yep, I'm an organic chemist. No, actually, I like almonds and cherries, especially. How many of you have ever had the maraschino cherries? You know, the real red ones that glow in the dark? Not really, but you think they might. All right, now for a ketone, find the longest chain or a ring. You can't have an aldehyde in a ring, but you can have a ketone. And you drop the E at ONE. For acyclic, meaning not in a ring, you need a number. What carbon is the carbonyl carbon? Carbon double bond to oxygen. For a ring, you don't, because that carbon is always going to be number one in a ketone that's in a ring. And give the IUPAC name for the following molecule. All right, my turn. And if we look at this, what's different? Ooh, an oxygen, double bond to carbon, carbon's here and carbon's here. That's a ketone. And how do we find that? Here's the carbonyl carbon. How many carbons are along this chain? Oh, it's a ring. And there are 5. It's 5-membered ring. Remember the cyclo, pentane. Drop the E at the end of pentane and add ONE. This is always number 1. Oh, on carbon 3, Dr. White's favorite alkyl group, a T-butyl group. So that would be T-butyl cyclopentanone. Now, I haven't done it for the aldehydes, so I should do the following. And why don't you draw the structure of 2-ethyl hexanal? Oops, that's not what I want. That's what I want. And don't forget, you can always ask me questions during my office hours or email me. And you can also go to the Chem 170 YouTube channel and go back and look at any videos you want to re-see any topic you want. Is that nice or what? Don't answer. All right, how do you draw the structure? How do you decode this name? You start from the right, move left. Al ending, aldehyde. How many carbons in the longest chain, including the carbonyl carbon? Well, if this were an E, hexane, 6 carbons. Now, you can write the carbonyl on either end. Dr. White loves writing it, like all organic chemists do, on the right. This is carbon 1, this is 2. It's got an ethyl group on carbon 2, ethyl 2 carbons, and there's 4 bonds to carbon. And say hello to my old friend, 2-ethyl hexanal. And this is a molecule I was able to use and exploit certain important properties of it for my first US patent. Hello, old friend. Now, there are 2 common names I asked you to learn. The simplest aldehyde, where R can be H, is formaldehyde. And the simplest ketone is 3 carbons, center carbon, carbonyl. Nobody ever calls that 2, I have to think about it. Propanol is acetone. And as I told you, formaldehyde is used in a number of things, but it's dangerous. And I won't ask it on test, but remember about the dangers of formaldehyde in wood products, especially from China. Even though it's improved, I'd still be careful. And if you ever have any questions about that, always feel free to email me. And acetone is one of the 2 called chemicals used as nail polish remover. I like those special effects I'm using on the last week. Awful humor Monday. And oh, instant replay again. Remember, carbonyl group. You should know how to draw it and how to describe it with words. Carbonyl group, carbon, double bond to oxygen, and here's the carbonyl group. Now, how do you make ketones and aldehydes? Well, these reactions we just went through, but I'll cover it again. You take a primary alcohol, oxidize to get an aldehyde. Secondary alcohol, oxidize it. The O in the bracket means that oxidize, you'll get a ketone. Now, a special reaction, one where you make a carbon-carbon single bond to make a ketone, is if you take benzene with an acid chloride, that's what this is, an aluminum trichloride, you make an aromatic ketone. And this is called Friedel-Crafts acylation, because with the carbonyl, no chlorine, it's called an acyl group. And here to bend in a line is a carbon there. So let's take this out for a spin. And the question would be, what are the two starting materials you would use to make that molecule? 6 points each. Not 6 points, 6 points, 3 each for each question mark. By the way, we're in test number 2 material. All right, is everybody done? Let's do this. All right, what's different? Ooh, I got a carbonyl. Carbons here, but I got a benzene ring here. That's different too. And what do you react with aluminum trichloride to make an aromatic ketone? Benzene plus an acid chloride. So one of these is benzene. Don't forget to put the lines there, circles in there. Otherwise, that's cyclohexane. Mark it wrong. What's my R group? Isopropyl. Carbonyl chlorine, 4 bonds to carbon. Remember, check that always. And that's how you do it. By the way, this is the most awful looking benzene ring. Excuse me. That's better. And that's how you do it. All right, now that we have a benzene ring, a ketone or aldehyde, what can we do with it? Now, next couple of reactions, I will never on the final give a synthesis. I will ask you to give the product or products. And because ketones and aldehydes in these reactions react the same way, a lazy way of doing, in which I'm an organic chemist, you notice I can take a ketone or an aldehyde. If R prime is H, it's an aldehyde. If it's carbons, it's a ketone. Alcohol, acid catalyst, keep your eye on the carbonyl carbon. That's where the fun is. And you form an semi-acetal, semi-ketone. If you react a ketone or an aldehyde with 2 molecules of acid or of alcohol and acid, you'll get an acetal or ketone. Now, a special case, which my PhD advisor, his advisor, came up with, Dr. Stewart, and that is how to protect ketones or aldehydes using ethylene glycol. And here we have a ketone or aldehyde, ethylene glycol acid, and we form this acetal or ketone. Notice the R groups are CH2, but they're bond together. And students forget this bond like I had on test number 2. Don't forget it. Now, once you make these compounds, what can you do with them? Well, if you take a hemiacetal or hemiketal, react it with acid and water, you get back the aldehyde or the ketone plus the alcohol you would have used to make that hemiacetal or hemiketal. And again, these 4 reactions, I'll never give you a synthesis problem, just straightforward reactions. And finally, if you take an acetal or ketal, and I forgot to put the H, and I forgot the prime by this R group too, missed it here. Let me rewrite this. I'm going to have a talk with whoever wrote those slides, straighten them out. All right. And when you see a molecule with 2 oxygens to the same carbon, these are the only 2 examples I know of in organic chemistry like this. You get back, it's an acetal or ketal. You get back the ketone or aldehyde you would have used to make that acetal or ketal, plus the alcohol you would have used. Now, if you need to, for this one, put a 2 there, feel free to, you don't need it. And that's how you do it. And as I mentioned, when we learned this, and now you know about it, these 2 reactions are how your stomach breaks down, especially the bottom one, how it breaks down carbohydrates, acid hydrolysis of an acetal or ketal. Oh, let's have some fun with this reaction. And it's not the one above, but why don't you try this one? What would be the organic product or products for a following reaction? In case you weren't watching, everybody see on the screen in the middle? Oh, excuse me for yawning. I think I caught the yawning bug. And for those who are finished, please be patient. I try and give everybody time to finish. All right, let's do this. What do we see that's different? Ooh, first molecule, carbon, double bond oxygen, carbons here and here. That's a ketone. Now, it could have been an aldehyde, but it's not. And remember, in a cyclic ketone, R and R prime and R double prime are connect together. Ooh, two of something. Carbon-carbon hydroxyl group, alcohol, acid catalyst. And what do you get? Keep your eye on the carbonyls. Carbon, what's attached to it is still attached to it. And then to the carbonyl carbon, we'll have two OR groups. Now, this whole thing here is my R prime and R double prime. It's my ring. So do you break carbon-carbon single bonds? No. So you'll still have the ring, you'll still have the methyl group. This carbon here, which is this carbon here, I have two oxygens. And what's my R group? This, ethyl. And that's the product you get. Again, I'll never put a synthesis this type of product. Now, Dr. White really had some fun now, and I get to talk about the work of one of my idols in organic chemistry, the great French organic chemist, Victor Grignard. And Victor Grignard, for next two reactions and a couple others, won the Nobel Prize in about 1910, 1915, give or take a few years either way. If you take an alkyl halide, react it with magnesium, you get a Grignard reagent. Remember, the magnesium is bonded to the carbon with the halogen, and the halogen is bonded to the magnesium. If you put the halogen first and the magnesium second, that doesn't exist, that's wrong. And the question is, what do you react with magnesium to make? Oh, I just had a brain freeze. Sorry about that. That even happens to Dr. White. What do you react with magnesium to make that compound? All right, my turn. And if we look at the product, what's different? What's not carbon? What's not? Ooh, magnesium chloride on a carbon. And what's that? That's the Grignard reagent. Where here, X can be chlorine, bromine, or iodine. And how do you react a Grignard? Or how do you make it? You react an alkyl halide with magnesium. And what's our R group? That. So I have 1, 2, 3, 4 carbons. I have a methyl group. Just think about it. 6 months ago, would you know what a methyl group is? Boy, have you learned a lot this semester. So proud of everybody, and I am. And the carbon with the Grignard will be the carbon with the halogen, which in this case is chlorine. I know there are 4 bonds to carbon, so I can put in the rest of the hydrogens. And why make this? Because this is a nucleophile. It attacks the carbonyl carbon of a ketone aldehyde. Later on, you learned about an ester in the Grignard reaction to form that special, very special thing, a carbon-carbon single bond. So if you take a ketone aldehyde, react it with the Grignard reagent, second step, that should be H plus H2O, and you form a carbon-oxygen, a carbon-carbon single bond to make an alcohol. This is very special, very rare in all of organic chemistry. And this is also one of the problems students have trouble with. And here's one for you to have fun with. What would be the product or products of the following reaction? And this reaction I will never give a synthesis problem on. All right, let's do this. If we look at here, what's different here? Ooh, carbonyl with the hydrogen, the carbons, it's an aldehyde. But it could have been a ketone or an aldehyde. And what are we reacting with? First of all, what's different here? Ooh, magnesium halide on a carbon. That's a Grignard. And second step, acid and water. And what happens? The Grignard attached to carbonyl carbon, opens it up, and you get an alcohol. Remember, keep your eye on the carbonyl carbon. That's where all the fun is. What's attached to that carbon is still there. This opens up to an alcohol, and you make that very special thing, a carbon-carbon single bond. So this is our R prime, our double prime, and the carbon with the Grignard is the carbon bonded to the carbonyl carbon. So let's keep our eye on that. Draw it. What's attached to it? R prime, R double prime, hydroxyl group. What's my R triple prime isopropyl? The carbon with the Grignard will be the carbon bonded to, oops. No. To the carbon with the hydroxyl group. And that's how you do it. I'd highly recommend you practice this. Hint, I said that for test number 2 also. All right, now, when you have a carbonyl group, you have a carbon oxygen double bond, a pi bond, and a sigma bond. And you know pi bonds, I can react with hydrogen and catalyst, nickel, platinum, or palladium, and you break the pi bond, and each atom now of the double bond gets a hydrogen. So you can take a ketone or aldehyde and convert it into an alcohol. Next, since this can react also with carbon-carbon double bonds, where you don't want it to, H.C. Brown of Purdue came up with a couple of reagents, and one he invented near the end of World War II was lithium aluminum hydride, which later on that and sodium borohydride, which I'm not teaching in this class, and other borohydrides, he won the Nobel Prize for. And if you take an aldehyde or ketone and react it with the lithium aluminum hydride and acid and water, you do the same thing, but the mechanism is a little different, but the same outcome. You break the pi bond, and each atom of that double bond gets a hydrogen. You make an alcohol, same as hydrogenation of a ketone or aldehyde, except this won't react with carbon-to-carbon double bonds, which makes it extremely useful. Now, As we look at the last reaction, remember the alpha carbon, the carbon bond to the carbonyl carbon has acidic protons. I can pull that off and form an enolate anion, which attacks the other carbonyl carbon, the second aldehyde, and forms a carbon-carbon single bond, opening that second carbonyl to an alcohol. And this is called the enol reaction, enolate, aldol condensation using enolate anions. It's an aldol condensation. And my gift to you is, which I don't have to, if you see the same aldehyde twice, no, you're not seeing double. You're saying Dr. White's gift to you because that's an aldol condensation. Here's the general reaction. Now, for test 2, because we're now getting into some interesting functional groups, we had the following. And there you are for your enjoyment on this Monday afternoon. Circle and name the functional groups, 2 points each. And I hope you're finding the review helpful. If you are, give me a thumbs up. Thank you. And thank you. Let's see if you are done. All right, I think everybody's done, so I better get to work. If we look, ooh, an oxygen with a carbon here and here. You don't have to write this, but I will. And that's an ether. Ooh, another oxygen. Remember, look for what's different. That's where the fun is. What do we have? Carbon, carbonyl, hydrogen. And what is this? It's an aldehyde. Ooh, and B, hydroxy group on a carbon. And what is this? An alcohol. Ooh, carbonyl, carbon, carbons here and here. And what's this? It's a ketone. We're not done. One more oxygen here. And what do we have? Again, this is an aldehyde. And you should know how to play that fun game, circle and name the functional group, 2 points each. Because if you don't know what the functional group is, how do you know the chemistry? And how do you know how to name that? Now, one thing I forgot to mention about the final, I think I might have, but I'll mention it. The way I have it set up is the first part is test number 1 material. The second part is test number 2. The third part is test number 3, then test number 4 material. And at the very end, new material, amino acids and proteins. And hopefully that makes your life just a little easier. And with that, I'm just about done. Don't forget, a week from today, starting at 1 p.m. when I send out the password, will be the final exam. You'll have until Tuesday, 11 a.m. Take it and upload it to D2L. Take up to 3 hours. I'm being very generous to finish it. And don't forget, I have my office hour tonight, and the lab is due on Wednesday. With that, I'm going to say, Gang gesund. Goodbye.